recording now. Is that recording? Yeah. Okay. All right. So here is your question. Okay. So given the root of a binary search tree or a BST, convert it to a greater tree such that every key of the original BST is changed to the original key plus the sum of all keys greater than the original key. In addition, using the same concepts in the previous function, write a function that returns a Boolean which checks if a BST is a greater tree or not. So once again, it lists like what are the requirements or like what are the properties of a BST or binary search tree, which is, you know, the left subtree does that, the right subtree does that. Both of them have to be, you know, binary search trees as well. This is an example to show you that how it works. So the bottom right node will always stay the same, and then it just increases with the sum. We give you an input and an output. So that's just kind of how it looks. So and I gave you the class, and I gave you the, I don't know, the two function headers, I guess. So you're only given the root, and for the what's it called? For the conversion, you give a new root, I guess, and for the check, you just give a Boolean value. But that's pretty much it. Do you have any questions?
No, I don't think so.
Okay.
Okay, let's see. Where would I start with this? Okay, we'll start with this BST to GST function. Okay, I'll need a few minutes to like get my thoughts together on how to do this.
Yeah, of course. Feel free to write out comments or pseudocode first, you know, however, whatever works.
Okay, so I definitely need to just traverse the tree somehow while changing all of the values. Can I make other functions within this?
Yes, you can.
Okay. Okay, I think the easiest method to doing this is just doing an in order traversal of the tree. And then creating a vector from the in order traversal of all values in the tree. And then using that to determine what the new values in the tree will be.
That's smart. I like that.
Okay, yeah, I'll do that. So this in order. Again, I'll traverse that. Yeah, I'll just use that. Root left. Well, yeah, I need to make a vector first. I think I need to pass it into this function as well. Wait, do I? Okay, this is like basic in order traversal. Not sure. I think I make a vector. Oh god, this vector synthesis. No. Do I just create the vector in this? Okay, we're gonna do include vector first. Things like this. Okay, we'll make a vector. Maybe we just need ints. Wait, are the values stored as ints, or can I just assume that?
Yes, of course, the values are ints, yeah. And
Okay.
they'll be greater or equal to 0.
Vector nodes. Let's do nodes push back root val. This works, right? Yes. Okay, I believe this should populate a vector of all tree nodes in order.
Wouldn't you have to pass the vectors like a parameter or some sort of reference for it to access it? Like, I guess, like, right? Like, how would it
Okay, I'm thinking
access it?
about that. Okay, wait, yeah, you're right. Okay, I'll pass it. Vector int add nodes. There. Okay, that should be fine. Now we pass by reference, so it actually changes the vector. Oh wait, I also need to do if I need to check if this is null or not. If okay, the spacing's wonky, but whatever.
Yeah, it's kind of annoying to type code on a Google Doc, but we do what we have to do.
Yeah, the tab is like huge. In order, root left, in order, root right. Am I forgetting something? Okay, I believe that should work. Okay, now. Okay, I need to determine the new values that will go into this tree. So I'll do. I'll run through this vector backwards, I think. Or in I at 0. Wait, no. Vector nodes dot size. Oops. I is greater than 0. I minus minus. Nodes. Okay, wait, I need to make it a variable first. In some 0 nodes I sum plus equals nodes I. Nodes I is sum. Does this work? Okay, I'm just gonna run through the example to make sure I did this right. So assuming I did the in order correctly, it should be, I'll just goes to 8, 5, 6, 7, 8. Nodes dot size is 7. Wait, no. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9. Sum plus equals 8. Nodes I is sum, so this would be 8. And then sum plus equals, so then 15, this will be 15. And then 23. Okay. Yeah, they should change all the vector values, this for loop, to what the values should be. Yes.
Yeah, it looks good.
And then I just change the values. I just modify the standard tree, right? Or do I make a new
Yeah,
tree?
you modify the
The
standard.
given one? Okay. I said just in order traversal it again. But I modify the values this time on this traversal. Probably more efficient way to do this, but in order reversal. Okay, let me just go do this. Be in order. Let's change. No. Oh wait. Okay, I need to pass in what number it is. So change this to this. I wish I K. And we'll do this. Oh yeah, I need to fix all my function calls. I messed up. Oop. And then I pass in K. Does this work? Left. Left. Let's visit this node. Oh, I know this should increase, not decrease. The function should be called like this. No, it's root. That should be 0. Nodes I. Yeah, because the 36 would be at where 0 is in the vector. Right? In order change, nodes val. Those nodes, K plus plus. In order change, vector nodes, left, K. Oh wait, I messed up this. Let's just say right. So shift this. Okay, I believe this should change all of the nodes to the correct versions of them. Or like the new greater search tree values. And we just return root. Okay, I think I'm done with this function. Okay, I'll move on to GST check now. How do I determine if this is a greater search tree? Every key to be original key plus sum of all keys greater. Okay. So I think to determine if it's a greater search tree, if okay, based on the example, I'm going to assume it will always follow the rule that while doing an in-order traversal, all the nodes should be less than or like in descending order.
That
So
is
I'll
true.
just
Yeah.
go with that. So I can just do in order. Nodes. Yeah, I'll name this differently. Actually, sorry, name the other one nodes. Check nodes. In order traversal. Check nodes. Root. For size 0, I is less than dot size. I plus plus. That is not supposed to be there. Oops. And current node is wait. I'll start this at 1 and just make this node check nodes 0. If check node I is greater than current node. Or no, I'll do less than. Oh, and make the boolean. Bool is GST is true. Is GST false. Wait. No. That should be this way, right? Because the current node should always be larger. So if the next node is larger, then it's not a GST. Yeah. Break. Then we'll do check current node is check nodes I. Because this should then be, it'll go from 0 to 1, and this will be 2, and then 2, and then 3. Current node check nodes I, and then we just return is GST. Okay, I believe this works, but I will just look over on my code again, just in case I like messed up somewhere. In order traversal, vector in at nodes, tree node root left, root
I am
right.
speaking with
Gail Lockman.
Root left, right. In order traversal, some nodes I is some. Okay, wait, this for loop has an issue actually, right? This should be I minus 1, and then I is greater than or equal to 0. Yeah. Okay. In order change, nodes root 0. Return root. Bool HGST vector and check nodes. Okay, I believe I am done with my solution.
Okay, cool. And it does look good. So, yeah, because I was looking through it too. I think that works. So it's good. Okay, I think you're done. So am I supposed to next show you a possible solution and then kind of go through actionable feedback, I guess? So let me show you.
Yeah, I think my solution's inefficient, but
I mean, hey, it works. And at least you say that. So let me stop sharing and share. Let's see, is this it? Which one is it? I think it's this. Okay. This is how, let's see. Yeah. All right. Can you see my screen?
yeah, I can see it.
Okay. So this is how they do it. So this is for the transform. So this is how they do it. They do it really, I don't know. This is how they do it. So they do, ignore that, it's their node stuff, but they do a recursive method.
Oh, so they just modify it.
They
So they
modify
do
like
roughly
in
the same
action.
thing.
Yeah.
But they do it like during the traversal instead.
Right.
Okay.
Yeah. Which obviously
Star
decreases.
sum equals star sum plus root data. Okay, I
Yeah.
guess that makes sense.
It's interesting. Yeah. So I added that little extra bit of checking if it's a GST because that's like easy, right? You just like do what you did. So like yours is like time complexity wise great. This one's just a little bit better from yours.
Yeah,
But
because
you guys
mine
did
will
essentially the
always.
same thing. You know what I'm saying?
Mhm.
So, but
I think
that's
I'm running at like O2N, but they're running at just like ON.
right.
But they're roughly the same thing. So
Right. Yeah, it works. So don't worry about that.
I didn't check for base case either on if root is null.
That's true.
That's okay.
It's okay. Let's see. I would say I liked a lot how you went through and checked like over and over. I like that because you caught like most of your mistakes. Um, think there's like a mistake in the beginning where you had like your in order calls wrong, like you forgot to include the nodes, and I had a feeling you were gonna correct yourself and you did. So anytime I thought I saw a mistake, you pretty much corrected yourself. Um,
Oh, wait, I just realized I actually wrote this wrong. They should all just say nodes.
oh
This.
yeah, I didn't even notice that, but yeah.
There we go.
There you go. Um, other than that, I'm trying to think. You talked out loud really well. Obviously, I think you probably, I mean, there obviously is a better solution out there, but you don't really have the time to like think and sit like, hey, like how can I like do this the best way? So I don't really
Mhm.
blame you for that. So you did it like a pretty good way. So I'm not gonna like shit on you for that. But otherwise, I think you did a good job. Um, you talked out loud. I don't know. I'm trying to think of anything else I forgot. I think just the thing is like sometimes you should spend more time planning and thinking of like a better way. It doesn't need to be the best way. It just needs to be like
Instead of
a
just like
better
hopping
way of,
straight in.
yeah, because I always hop straight in and like do the crappy solution first, and that's not always the best,
Mhm.
especially for coding interviews. So
Yeah.
but otherwise, great job. Yeah, good stuff.
All right.
It's a
Thank
weird
you.
problem. Yeah.